Hello, once again, welcome to Physi Dive, and this is your teacher Alexi Rajan. Today, we are going to study about very important topic of class 9 NCRT, that is equations of motion graphically. We had completed equations of motion analytically or mathematically, and those who haven't gone through that video or class, I'll pin somewhere and you can just go through. And now, without wasting time, we are just directing straight to the class. So equations of motion, the equations of motion analytically. And what are those equations of motion? So we have studied about three equations of motion. The first equation is v is equal to u plus at, and the second equation is s is equal to ut plus half at square, and the third equation is v square is equal to u square plus 2as. And what is the scenario? The scenario is like this, that is, there is a coordinate system and there is the origin, and just imagine that an object is here and which is having an initial velocity u, and it is moving to a particular distance or displacement, and that displacement is s, and this body had done its displacement in time t, and the body has reached to its final destination. And if I calculate the final velocity, then I can say that the final velocity is v. So these are the credentials for this particular scenario, and using these credentials we got this much equations. So we had proved it mathematically, and those who want to see it once again, I will pin it somewhere here and you can go through it and just have a revise. Okay, so now we need to find it graphically. So how can I prove it graphically? So before proving this graphically, we need to get familiarized with the types of graphs that we need to study in class 9. Okay, so what are the different types of graphs? So graphs are mainly two types, not two types, but for our standard, graphs are mainly two types, and those are, the first one is displacement time graph, and the second graph is velocity time graph. So what do you mean by this displacement and velocity time graph? So I had taken class for this displacement and time graph specifically for graph in class 11 NCRT. So specifically for graphs, and you can go through that video also. It's very simple. Don't think that it's for 11th standard. You will also understand if you're going through that thing. So I'll pin it somewhere here. You can go through the thing. But still, we'll just get familiarized with the graph for class 9 also. So the next topic, that is, what are the different types of graphs? So we have two types of graphs in the hands, and two datas are given here. So what are the two datas? This is one data, the first data, and this one is the second data. And using that data, you're going to plot a graph. In the first data, the graphs are to be plotted between displacement and time, and you are given with displacement data and time data, and you're going to plot a graph against displacement and time. So using that displacement and time, you are plotting a graph with certain data in your hands, and you are saying that what type of graph you are plotting, that is the displacement time graph. Why? Because your data are displacement and time. Whereas in the second graph, if you see closely, you can see that the data in your hand is velocity and time, and you are using those data to plot a graph, and the graph is between velocity and time, and you are calling it as what? As the name suggests, you are calling it as what? Velocity time graph. And we will get certain graph, and those graphs are known as what? Displacement time graph and velocity time graph respectively. And here is a basic physics behind graphs. So certain informations are there to be obtained from this particular graphs, and what are those equations or what are those informations that we are going to study right now. In the first case, that is the displacement time graph. According to the data in your hand, you can see that the time in 2 seconds, the object is displacing 2 meters. Okay, I am just taking this meters and second as a unit. So 2 meters. In 2 seconds, object is having a displacement 2 meters. In 4 seconds, 4 meters. 6 seconds, 6 meters. 8 seconds, 8 meters. So if I am plotting a graph, then what will I get? Then I will get a graph like this. See, I got a graph like this. Actually, the data is not complete again. The thing is that it is not clear that at 0 second where is a body, but I am taking it as this at 0 second the body was at the origin itself. So I get a graph like this. Here the importance of this graph is that it is a straight inclined line. If you're getting a straight inclined line, that means the object is having what type of motion? The uniform motion. The object is displacing equally in equal interval of time. So please go through that uniform motion chapters, videos and all. Please kindly go through that thing, then only you will get all the things, all the physics ideas behind this particular graph. Okay, it's all in our channel, so you can just again rewind all those things. Okay, now you got a straight line. Straight line implies or indicates what? The object is having a uniform motion. The curved line indicates what? The object is having a non-uniform motion. We will just see some more indications what is a actual meaning or informations that we are getting out of this graphs. Okay, so I'm just rubbing the velocity time graph. We will come to velocity time graph now itself after completion of this particular displacement time graph. Now, if I'm taking the slope of a graph, what do you mean by slope of a graph? Slope of a graph means the tan theta. So just imagine that you are having displacement time graph and you got a graph like this. Then the angle between the time axis and the graph is theta. Just imagine this is theta. This tan theta from here is nothing but the slope, and tan theta is equal to opposite by adjacent, that is AB by OB. And what is AB? AB means it is nothing but the displacement. So it is displacement by what is OB? OB is nothing but the time. So displacement by time. So the slope of a graph, if I'm taking the slope of a graph, then I will get what? I will get displacement by time, that is nothing but the velocity. If I am finding out the slope of what type of graph? A displacement time graph, then I will get what? The velocity. So two main informations you are getting out of this particular graph, and that is if I'm getting a straight line and a curved graph, then I will understand whether the object is having uniform motion or non-uniform motion. And if I'm finding out the slope is what? The tan theta, then definitely I will find out what? The velocity of the object under that particular movement. So that's all, and these are the informations that you are getting out of this displacement time graph. So now coming to the velocity time graph, what all informations you are getting out of this velocity time graph? So here is a velocity time graph. Just imagine that according to the previous data in your hand, you're getting a straight line inclined graph there. So what is this straight inclined graph or means? What does it indicate? What does it indicate? So it indicates that the motion is having a uniform acceleration. If you are getting a curved graph, that means the object is having non-uniformly accelerated movement. So just identify and understand the actual meaning behind graph. Okay, so this is the first case. Now, if I'm finding out the slope of a graph, so what does you find or what will you find? Imagine that this is a theta. So it means that the graph means that at 0 second, like, okay, if this is 0, then at 0 second it is at 0 there. So u is 0. And what is this one? At time t, then you are getting a velocity v. Just imagine like that. So final velocity is v. Okay, and the time interval is t. So this is a case there. Now, if I am finding out the slope of a graph, slope means it is a tan theta. Okay, you must understand all these things. And tan theta means opposite by adjacent. So it is AB by OB. So what is AB? AB means this here, right? AB means V or V minus U. You can simply say like that, V minus U, or simply here as U is 0, you are getting it is V minus U, and that is equal to or divided by what is OB? OB is T. So V minus U by T. This is the equation that you are getting while you are finding out the tan theta or slope of a graph. And what is this? What is it? From the first equation of motion, you know that V is equal to U plus AT. From there, V minus U by T is nothing but the acceleration. So you are actually getting the acceleration if you're finding out the slope of a graph. So if you're finding out the slope of a velocity time graph, you will definitely find out, or you will get the acceleration. So slope of a velocity time is acceleration. A straight incline graph defines, or it gives you the idea that the object is having a uniformly accelerated movement, and a curved line graph will give you, what type of graph? Velocity time graph will give you that it is a non-uniformly accelerated motion. Now, one more very important application or informations you will get out of this particular graph. A velocity time graph. I'm taking this case for our convenience, velocity time graph. And you are getting a straight line but parallel to the time axis. What does that indicate? This means that the object is at rest. This means that the object is having a uniform velocity. Uniform velocity means what? This means that the object is having a uniform velocity. So, what does that mean? Okay, it means that at each time interval, your velocity is fixed. Your velocity is fixed. There is no change in velocity. That means the velocity is constant, or simply you can say uniform motion. Here the acceleration will be what? The acceleration will be 0. Why? Because there is no increase in velocity. Velocity is constant throughout its motion. There is no initial velocity and there is no final velocity, nothing is there. Only a constant velocity is there. So you are having a uniform motion, or simply zero accelerated movement. So this is an indication of a straight line graph. What straight line? What type of straight line? The straight line parallel to the time axis. So this is another indication. And one more very important thing is that just imagine that this is a case. Okay. And here, if I am finding out area under this particular graph, then what will I get? Area is equal to length into breadth. AB into breadth. Breadth means BC. So AB into BC. So what is the area there? So area AB. AB means what? AB is nothing but OC, that is equal to time into BC. BC means what? BC is nothing but it is the velocity. So velocity into time. So if I'm finding the area, I'll get velocity into time by common the basic equation. Velocity into time is nothing but it is a displacement. Here comes the next very important information that you get in a velocity time graph. That is nothing but the area under a velocity time graph will give you what? The displacement. So what all information you are getting, whether you are finding whether it is a uniformly accelerated motion, non-uniformly accelerated motion. The second one is that if you're finding out the slope, then you will get what? You will get the acceleration. And next one is that if you're finding a graph that is parallel, that is straight line and parallel to the time axis, then that graph or that object is having zero acceleration, or it is having a uniform motion. It is not uniformly accelerated motion, it is uniform motion where the acceleration is zero. And the next thing is that if you're finding out the area under that particular graph, then you will get what? The displacement of the object. So these are the information. These are the informations that you are getting out of a velocity time graph. Now, I hope that you got the physics or idea behind the graphs. Now, after all these informations in your hand, we are going to find out or prove the equations of motion using graphical method. So here comes the equations of motion using graphical method. Okay. So here comes the first equation, that is V is equal to U plus AT. And you are given with a graph, whatever graph, velocity time graph. Here you can see that the object, this is the origin and this is the initial velocity and this one is the final velocity and this is the time interval t. Okay, now you are asked to find out value, that is V is equal to U plus AT. So here you can see that if I am taking the slope of a graph, this is theta. The slope of a graph for a velocity time graph will give you what? The acceleration, that is nothing but the tan theta, and here tan theta is equal to opposite by adjacent. So BC by, I'll just name it as D. Okay, then BC by AD. And what is BC? BC is nothing but, sorry, here it is not BC, it is BD. It is BD by AD. And what is BD? BD is nothing but it is this value can be found out by BC minus DC. BC minus DC divided by AD. And here you can see that slope of graph is nothing but it is an acceleration. A is equal to BC. BC means this total. Total is nothing but the total velocity, final velocity. So V minus what is DC? DC is nothing but U, that is initial velocity, divided by AD, that is this one. This one is nothing but the time. So it is the time t. So A is equal to V minus U by t. So from there you will get AT is equal to V minus U. From there you will get the answer, that is V is equal to U plus AT. So here is a first equation, that is V is equal to U plus AT. Simple thing, you are finding out, you are taking a velocity time graph and then you are finding out the slope and then you will get the acceleration, and the value you got is V is equal to U plus AT. As simple as that. It is much simpler than the analytical method. Now coming to the second equation of motion. So to the second equation of motion. So here is a second equation of motion and you are given with a velocity time graph once again, and here you are asked to find out S is equal to ut plus half at. S is what? The displacement. And you know that from the graph, how can you find out the displacement? By finding out the area shader or area under the graph. So this is the area under the graph. And you can clearly see that this is a trapezium. For here, we are not directly taking the area of the trapezium. Instead, we are finding out or just finding out the area of this particular triangle, or you can see that this particular triangle, this rectangle, and then you are just adding that particular area with this particular triangle. Now you can see you are finding out the total area under that particular graph. Just imagine that you are finding out the area, and area is nothing but the displacement or capital S. So here the area is equal to area of triangle plus area of the rectangle. Okay, now what is the area of this triangle? So half into length into breadth, half into length into breadth. So length is this one, right? So you can say length into height, you can say, or base into height, half into base into height. So that would be better. So here the base is AC into height is BC. So this one is the height and this one is the base. Plus what is the area of rectangle? OACD, or area of rectangle OACD, and area of rectangle OACD is length into breadth, that is OA into OD. So this is the thing, right? So this is a length and this is the breadth. So now we are just substituting those values. Half into AC. AC means what? This one is AC, right? AC, or this length, and that is nothing but the time. That is nothing but the time. Into what is BC? What is BC? This one is BC, right? BC means it is not the final velocity, but you can find out this BC can be found out by finding what? That is total BD minus CD. BD minus CD. Okay, BD minus CD. Plus what is OA? OA, that is this one. OA. OA is nothing but the initial velocity. So initial velocity into what is OD? This is nothing but the time. So you can, I am just taking this word first. So you will get UT plus this word, this terms. Okay. So half into T into what is BD? BD is the final velocity minus what is CD? The initial velocity U. So from there, UT plus half into T into what is V minus U? From the first equation of motion, you know that thing V is equal to U plus AT. From there, you will get V minus U is equal to AT. This is one equation, right? And you are substituting this value here, and you will get T into AT. From there, you will get area is nothing but the displacement, right? Displacement is equal to UT plus half AT square. So here you are getting the second equation of motion, that is S is equal to UT plus half AT square. Simple thing, you are just finding out the displacement by finding out the area, and area you are just finding out by area of the triangle here, the triangle ABC plus area of the rectangle OACD. and you are just doing basic mathematics and you are getting the value that is S is equal to ut plus half at square. So this is the second equation of motion graphically. Within fraction of seconds, you can find it out such a easy manner. Okay, now you don't need to take the average velocity like that in the mathematical method. You simply simple physics and concept. Now coming to the third equation of motion, how can you find it out? So the third equation of motion goes like this. Here also the third equation of motion, we are just having the same concept by finding out the area under this graph. So the area under the graph will be this area, right? And this is nothing but a trapezium. So here also we are just starting with finding out the area of the graph, and the area of the graph is equal to area of the trapezium. And here fraction of second we are going to find it out. What is the equation? V square is equal to u square plus 2as. So here the area of trapezium is given by half into sum of parallel sides into the displacement or the breadth. So this is the area of a trapezium. So that is equal to half into, the area is nothing but the displacement, half into what is sum of parallel sides. This is a parallel sides, right? That is OA plus BD into what is the displacement? Here it is the OD. So that is nothing but the time itself, that is half into OA. OA means it is U plus what is BD? BD is nothing but the final velocity V into time. So this is a case there. So here comes the equation. Equation is over. Pure mathematics is over. So now we are going to substitute some values and get into this particular form. Okay, now you know that thing, that is the second equation, or V is equal to U plus, first equation V is equal to U plus AT. From there T is what? V minus U by A is nothing but T. So instead of this T, you are substituting this value here and you are getting the value like this, that is half into U plus V into V minus U by A. This is equal to S. Now S is equal to V plus U and V minus U. What is that? A plus B into A minus B is A square minus B square. So here V square minus U square divided by 2A. Here comes the equation. Okay, so the equation is over. So here you are just substituting, rearranging the values, and you are getting V square minus U square is equal to 2AS. From there, V square is equal to U square plus 2AS. This is nothing but the third equation of motion. That is, V square is equal to U square plus 2AS. So here also we are doing the same method, same concept, by taking the velocity time graph, finding out the area, and then finding out the area of the trapezium, and you are getting into that particular third equation of motion, that is V square is equal to U square plus 2AS. And I hope that you got the points, you got the physics and concept behind how to prove graphically the equations of motion and what are the informations that you are getting out of the graphs. So that's it, guys, and I hope that you got the points there. Study well. I'll just pin the videos that you require as a prerequisites for this particular class, and just go through those videos also, and we'll come with new topics for class 9 NCERT in the coming classes. And stay tuned, and we need your support by your like, share and subscription. So just be supporting. We'll see you in the next class. Till then, goodbye and have a nice day.